Sorry, that was my daughter on the phone. Okay, so on F, it's good to break the video up anyway. So on F, we have three things going on here. The outside function is actually a cube. Okay, let me rewrite this so you can see what I'm talking about. All right, so this is all right. The cosine of e to the 5 theta. That's a weird one. All right, whole thing cubed. That's what that means. All right, so this is crazy. The outside function is a cube. The next inner, this is where this chain rule comes in. We got a chain of functions. The next inner function is a cosine. The next inner function is e. And the most inner function is 5 theta. All right, this one's crazy, but I think it's fun. All right, so what happens is you end up with a chain. You cannot take derivatives at the same time. So the first derivative is going to be a power rule. We're going to drop the 3 down. We're copying every single thing. So this is with respect to this entire cosine. We've not done that derivative yet. We've not done this e derivative yet. We've not done the 5 theta. That theta's or it could be x, We haven't done any of that yet. You're copying all of that down. Do not take derivatives at the same time. That's the most outside part. Now, the next inner part is the cosine. Well, the derivative of cosine is negative sine. So it's going to be negative sine. And again, that's it. You copy everything else down. You don't take two derivatives at the same time. So I'm going to copy e to the 5 theta. Parentheses are not there either way. It's fine. All right. If you want to, you can. All right. And then I take the derivative of the e. All right. So the e, so times e, and then I copy. And in our final chain rule, it is the derivative of 5 theta, if theta is our variable, which would be times 5. Man, there ain't a lot to do to clean that up because you've got cosine, you've got a sine. You do have a negative and a 5 and a 3 that all could come together. So if you want to, and you don't have to, that would be a negative 15 and then a whole bunch of stuff we got to write down. so this cosine squared, just to make it look a little neater, e to the 5 theta, okay, times sine e to the 5 theta, and then times e to the 5 theta. Whoa. And some people may put that e to the 5 theta up front, so it'd be a negative 15 e to the 5 theta, cosine squared, e to the 5 theta, sine e to the 5 theta. Whoa. All right, that one is wild. All right, so looking at G. Okay, well, I'm thinking on G, probably a good idea would be to go ahead and rewrite this instead of because remember, like if I had the natural log of x squared, I could rewrite that as the same as 2 times the natural log of x. I'm thinking about doing that instead of doing a chain rule this time. I just want to drop that 2 down. It's still going to be a chain rule, but I don't want to do a chain rule with this exponent. I want to drop that down. So logarithmic rule is this is the same as 2 times the natural log, and now we've got an inner function, x squared plus x plus 1. Okay. All right. Yes. Okay, so that was logarithm. That's no calculus. All right, so then f prime then, the derivative, is going to be constant multiple. So I've got 2. All right, and then the derivative of a natural log is 1 over. So it's going to be 1 over x squared plus x plus 1, right? So I'm copying all that. 1 over copy. All right, so still the same deal. Then your chain rule, though, because you do have to take the derivative of the x squared plus x at some point, right? So the x squared plus x derivative then is going to happen, and it just happens right next to, not in the bottom of the fraction, it's right next to the fraction, and I'm going to need a parentheses here to show it, 2x plus 1. Okay, that doesn't factor. There's no reducing that can happen. I can clean it up a little bit. My numerator, I'm just going to leave it in factored form. So my numerator, I'm going to call it 2 times 2x plus 1. Right? And my denominator, I'm going to call x squared plus x plus 1. Whoa. All right. And oh my gosh. Okay, so look at H. We have a product, and the derivative of the second is going to need a chain rule. But hold on a second. Oh my gosh. All right, there's some stuff I can do here. I've got a -4. I could place it back up there. The e to the natural log of that would definitely clean up. Okay, this one's very interesting. Okay, I don't think I want to do what I just said I'm going to do. This is x squared, all right, times e, logarithm rule, natural log of x to the -4. Oh my gosh. All right, that's pretty cool, because then the natural log of e to the natural log of x to the -4 is x to the -4. So this is x squared, right? And then times x to the -4. So this is equal to x to the -2. And now I can do power rule. Hey, all right, so now power rule on that is going to be -2x to the -3, which is -2 over x cubed. All right, cool. We'll pause on that one. Hey, doing all right?